presentations later. You should see confirmation pop up in your Zoom window. Other than that, I think we will go ahead and head off with our first presenter. Jenna Sackler is going to give her capstone proposal on the Insider Leak, designing and developing a public restroom locating mobile app in Washington, D.C. for convenience, tourism, and social justice. So Jenna, whenever you're ready, you can go ahead and take it away.
Thanks so much, and good morning, everyone. My name is Jenna Sackler, and for my capstone project, the first half of which I completed during 596A, I decided to build a location-based services app to locate public restrooms in Washington, D.C., which is where I live. The title of this app is The Insider Leak, making a play on, Washington insiders, gossip, that sort of stuff, and a bit of a play on words with leak. I thought that was kind of a fun and lighthearted nod to the location of where the app is going to be focused. The genesis of this project is that I love taking long walks or bike rides around DC. This is a hobby that only grew during the pandemic. However, I do not always want to or have the cash on hand to buy something at a coffee shop to use their restroom. Similarly, during the pandemic, a lot of coffee shops or restaurants had their bathrooms closed to customers. While I generally knew where the free public restrooms were on the National Mall, even though those are themselves not always reliable because they're often closed for repairs, I was out of luck for other areas of the city. So I thought this was a great app to build that I myself would enjoy using. And as I dove further into this topic, I discovered there were so many more layers to the public restroom access issue, and then decided it was a great topic on which to apply the skills I've learned throughout the MGIS program. In this presentation, I will follow the roadmap shown on this slide. I will quickly run through the background for my capstone project, the methodology I'm using for software development and project management, my new and existing data sources, the user experience or UX requirements process, my actual plan for app design, potential funding sources to move it out of the prototype stage, a notional project timeline for the next semester of the MGIS program, and then the references I used while building this presentation, just for your awareness. So first, background. This screenshot shows that the current public restroom situation in DC is not ideal. While there are plenty of restrooms located on the National Mall, though as I noted, those are often closed, outside of there, options are pretty slim. There are a few in Rock Creek Park, administered by the National Park Service, and a few in other public parks, but otherwise, really nothing. And certainly nothing available on Google Maps. This is a common situation for US cities, but it stands in stark contrast to other major cities in the industrialized world. As I mentioned in my introduction, there are many layers to the issue of public restroom access. In addition to convenience and support for tourists or other people just out and about for the day, such as myself on my long walks, there are real social justice issues at stake. Availability of safe, clean, and accessible public restrooms, and the ability to locate them in a timely manner, is vital to allow fuller participation in society for people with disabilities, unhoused people, women who may not feel safe in certain areas, and employees of industries where access to facilities is not guaranteed. For example, construction workers, taxi drivers, or truck drivers. Now, understanding the social justice and accessibility side of public restrooms access, in 2019, the DC City Council passed legislation to construct 2 additional public restrooms away from the National Mall, as a pilot for hopefully more later. Unfortunately, implementation of that plan was sidetracked by the COVID-19 pandemic, but in April 2021, the DC Department of General Services picked it back up. It is very exciting that DC is starting to wake up to this issue. But even once the 2 new restrooms are built, which is also not many given the size of the city, a location-based service is still needed to locate them so that potential users can find them in a better way than just stumbling upon them. So what does a restroom locating service look like? Well, the American Restroom Association, which I didn't know existed until I started this project, provides very thorough guidelines for designing public restroom locators. I've listed them here on the slide. Some of the key features or some of the key criteria include, important attributes such as whether they're portable or in government buildings, or if there's any potential security restrictions for accessing them, a key or whatever. Similarly, if they're, single restrooms or if they're stalls, gender separated, all sorts of really important attributes. I will first use these guidelines to evaluate some existing public restroom locators. And then more importantly, as I go through and design my own app, I will use them to evaluate it. The next 2 slides just show some exemplars of public restroom locators around the world. This one is the Great British Toilet Map, which was created by an academic consortium. And I assess it to meet pretty much all of the American Restroom Association's criteria. It provides really detailed attribute information. You can edit it. It has accessibility to get directions and all sorts of really important things. The only issue is that it's a web-based map. So it's a little challenging for users to potentially access when out and about in public. It wouldn't be optimized for a mobile phone. There we go. Similarly, the Australian Government Department of Health created the National Public Toilet Map. While this one isn't quite as aesthetically pleasing as the Great British Public Toilet Map, it similarly provides a ton of information, directions, the ability to edit or update toilets, everything you might need. Although, again, similar to the Great British Public Toilet Map, this is a web map, so it is not optimized for mobile users. There are several mobile applications to locate public toilets, a few of which cover the United States. And however, of those, originally I discovered 6 mobile apps to locate public toilets that are currently published on either the Google Play or iOS app stores. However, only 2 cover the United States, including DC, and only 1 is available on both app stores. Flush, the app shown on the left, is the app that's available on both app stores. It contains a lot of attributes about each toilet, accessibility, conditions for entry, such as whether you need a key or a code or something like that. Users can also update data, they can link to Google Maps, all the basic criteria. However, aesthetically, I find the use of black icons against a primarily gray base map kind of challenging. Further, Flush does not meet all of the American Restroom Association's criteria for a locator because it does not list a facility's hour, and it does not include private establishments, and it does not immediately, in a way that is eye-catching, discern between different locations such as parks, municipal buildings, or portable restrooms. The app on the right is called Where is Public Toilet? This is only available on the Google Play Store, but it does contain much more information about each toilet and provides more filtering options and has similar, navigation capability, and continent level data sets are available to download for offline usage. However, Where is Public Toilet also does not achieve all of the ARA's, the American Restroom Association's criteria, because In contrast to Flush, it almost exclusively features restrooms in private businesses, missing several known restrooms in public parks or facilities. So reviewing the pros and cons, both of the international web apps and these mobile apps that already exist, was an important step for understanding the requirements that I might need in my own app, which allowed me to move on to the next phase of my project. And after understanding this background, it was time to move to the actual development. To manage this project, I'm going to use Agile software development methodology. Agile methodology entails constant iterations of requirements definition, design, prototyping, and coordination with the customers in short sprints. It incorporates much more customer feedback throughout the process than traditional waterfall style software development. In waterfall software development, all requirements and scheduling is decided up front. While this might be useful for really big, unwieldy projects where you need everything very, set by the minute, basically, waterfall might be preferable. For a small, quick project, I found the flexibility inherent to Agile software development preferable. Some additional pros and cons about using Agile methodology are listed on this slide. Some of the pros is that it's more efficient and allows for constant refinement and flexibility. And since I'm a small team of one person, I'm able to take advantage of that, sort of in good times flexible, in bad times possibly confusing environment. Some of the cons is that it's a self-initiated project for this capstone. The customer for now is fictional, although as you will see later in the presentation, there's a potential opportunity to try to partner with the DC government. Similarly, not having a set timeline, such as in an Agile software development, means there's some potential to get off track. However, I'm confident that I'll be able to stay on track and prefer Agile methodology. Now, once I've chosen that, it's time to move to the first really big step, which is the data. The existing data sets that I will incorporate into my app include the Google Maps results shown in the beginning of this presentation, which is approximately 10 restrooms and incorporates all the ones on the National Mall and other known public restrooms. The 26 locations of the DC public libraries, because libraries are generally free to access. The 6 restrooms available in Rock Creek Park, which is administered by the National Park Service, and additional restrooms located in a DC Department of Public Works report that was published pursuant to the 2019 Public Restroom Law. I'm not sure how many are in there right now. I'd have to go back and check. Additionally, a colleague of mine recently highlighted another quite large potential data set, and that is grocery stores. A lot of them have public restrooms and often, don't need proof that you're a customer purchasing anything to let you go use them. So that's another data set that I'll investigate for adding into my app. However, I will likely still need to locate more bathrooms. So I'll turn to field data collection. To conduct this collection, I will use Collector for ArcGIS on my personal mobile device. Now, I'm certainly not going to visit every single street in DC because that would take a lot longer than I have. I will try to cover all major pedestrian thoroughfares and business districts and really try to focus also on some of the underserved areas of the city in wards 7 and 8 across the river, because I think those will likely have fewer public restrooms, but a greater need for the ability to access them. All of that data I will populate into a relational database. Now, I know we all learned this in some of our earlier classes, but a relational database is the foundational method for storing geospatial information for later use in complex applications. It consists of multiple tables, each highlighting different attributes, all linked by keys. This slide shows a notional relational database that I would use as the basis of my application. The public restroom locations were drawn from the Google Maps data. This certainly isn't all of the attributes I'll include in my app, but it highlights some of the key ones. All right, so once I've taken a good look at all the data, it's time to begin the user experience requirements process. First, I will create a survey, probably using Google Docs or Doodle, and provide it to several dozen residents of the greater Washington, D.C. area, including my colleagues and my rugby team, all longtime residents of the D.C. area in a variety of demographics. The purpose of this survey is to verify app functionalities that will support user experience that I already thought of, as well as identify new ones that I might not think of. The questions located on this slide are some, but certainly not all, of the possible questions I will use in this survey. After collecting my survey responses, I will use those and additional research to create user scenarios. User scenarios, based on detailed research of expected potential users, allows designers to understand why someone's using the application through investigation of how they use it, which can provide invaluable insight into necessary functions and user experience requirements. I will create at least 3 user scenarios outlining detailed potential ways that my app might be used. And that, I will also review those scenarios with potential users for an additional step of verification. After that, I will move on to prototyping. Prototyping is a key step in the requirements refinement process, especially when using agile software development. And throughout the prototyping process, at each stage, you need to walk potential users through the prototype to ensure you continue to meet all of the requirements. I will use several different stages of prototyping, starting with just a paper prototype to understand the functionalities, where different parts will go, how the data will look in the app, I guess. I'll move through low fidelity and high fidelity wireframes using an online service such as Balsamic to really look at how I want the app to look, how I want it to function on a phone screen, using those, because that's possible using these online wireframing services. Finally, I'll create a fully functional prototype and use that to conduct a full cognitive walkthrough with potential users, where essentially they use the app as they normally would in a closed environment and provide feedback. So in looking at that fully functional prototype leads me to the next step, which is the actual app design and what actual platform I will use to build it. I will either use Esri's ArcGIS App Studio, or I will use free and open source software such as Apache Cordova. Both have their pros and cons. While ArcGIS App Studio is expensive at $500 for a basic license, I think it will ultimately end up being the better choice because I am a novice app designer, and this system would minimize coding and provide the full strength of Esri support. However, free and open source software can't be discounted because while it is code intensive, it is more customizable. So that's a big decision, although frankly, I think I'm likely to choose the App Studio. Final question is potential funding sources. There are many ways to fund an app, some of the most well-known of which are listed on this slide. For my app, I'm going to focus on 2, bootstrapping and identifying grants. Bootstrapping is the first method, which involves the developer raising the money themselves or with the support of personal connections. This is certainly possible for my capstone because It's pretty inexpensive app development. I'm a solo developer slash employee, and my only real overhead cost would be ArcGIS App Studio, since I'm unlikely to truly publish this onto an app store, although we'll see. This is also beneficial because the developer is not beholden to other organizations. It allows, the fullest creativity and the most iterations of development, as many changes as the developer wants. The main con of this is, of course, you're using your own money. But again, for this project, it's not that much. The next option would be to seek grants, or in particular, one grant. In fall 2021, the Washington, D.C. government's Department of Small and Local Business Development was scheduled to launch a funding call related to the new public restroom installations. As of this time, that's not yet been opened, but I do keep checking to see when that funding call might be open. Pros is the DC government will be able to provide more financial support than I could, through bootstrapping. Another pro is the potential connection that would bring to other developers or individuals working in different parts of, a similar field who are passionate about this public restroom access issue. Of course, the con of that is that you are beholden to an outside organization, in this case, the DC government, for final product delivery. So you have less ownership over your product, your data, etc. So that's another decision I will have to make shortly. This slide highlights a notional timeline for next semester to develop the app during 596B, aiming at presenting it at the Esri Developer Summit in California in March. For that summit, at which I'll have to have the app at least to a functional prototype stage to have something worth presenting, user presentations are voted up, and there are prizes or honors, at least, for some of the top user presentations. So if this does go through, I'll definitely be reaching out to the rest of the MGIS students to help vote me up. And then the app and the written report, which are the two main deliverables, will need to be finished by May when 596B ends. And finally, these are just the references I used for your awareness or your information if you're interested in learning more about public restrooms, location-based services, or Washington, D.C. Thank you, and I welcome any questions.
All right, Jenna, thanks a lot for that interesting proposal. That certainly has an incredible practical side to it. While we're waiting for questions, I have a thought. I don't know if you've considered this or not. There was an app, I guess, or I think probably back then it was just a website, Gawker Subway, New York City. And what it did was it allowed people to comment on the subway entrances. So people know where the subway entrances are. But the other aspect of it was, particularly for tourists that would come to the city and have no real idea about the condition of the subway entrance. So kind of that extent of volunteer geographic information. Had you thought about providing an outlet or a medium for people to comment on the toilet, yes. The condition, right?
Yes, I definitely, one of the things, obviously I'll verify this through my requirements process, but I definitely intend to have a way for users to not only add new toilets, but to add reviews or comments on ones they've used. And
the unique thing about the Gawker was that there were little emojis that you could include. So you'd have like cool. a little poop emoji that it smelled real bad, or you could get real creative here.
Absolutely. No, that's I'll definitely look into that. That's a great idea. Thank you.
There's a question in the chat window.
Yes, I see that. Is there student, so Blake asked, is there student pricing for the Esri App Studio? And do I see myself maintaining this app into the future? I looked for student pricing for Esri App Studio and I couldn't find any, but that might be worth a quick email to Esri and to see what they can do. Certainly possible. And then, do I see myself maintaining this app into the future? I think if I were able to get the grant from the DC government, yes. If I'm just bootstrapping, probably not, because maintaining an app, especially publishing it on the App Studios, gets kind of expensive. So it needs sort of outside funding. But if it works well and looks pretty, I definitely would like to. Some additional questions. Have you considered other prototyping software that are free to use as opposed to Balsamiq? I certainly would research other ones. Balsamiq is just the one that I used previously in one of my MGIS classes on app development. So that's just the one that came to mind first. I'm certainly not wedded to it, and we'll do some research on different ones and what sort of has the best functionality and for free. All right, my advisor, David, asked, can you discuss how your app might serve users in parts of the district where no Wi-Fi is available, i.e. offline functionality? I definitely intend for there to be some offline functionality in terms of being able to pull up the attributes and just a basic map of the toilets. Unfortunately, real navigation and probably editing would not be possible in the offline functionality, but that's definitely something I'm going to explore, at least having the map available so that users who are not in mobile or Wi-Fi signal range can still use the app. Steve asked, will the data you collect be available as a data layer that can be added to a more comprehensive citywide public services repository app website? That's definitely my plan, to reach out to the DC GIS department within the Office of the Chief Technology Officer. I'd gone back and forth about whether I wanted to keep my data private or make it public, but I think ultimately, given how I'm interested in the social justice aspect of this, I think I would make all data public and hopefully be able to proactively add it to DC's GIS repository. Yeah. If there are not any other questions, I'll stop sharing.
Yeah, Jenna, if you could put your email in the chat window so that
Sure.
if someone has a question later, they can ask.
Yes.
But otherwise, great job. And then stop sharing your screen.
I didn't do that wrong. Sorry.
No, that's all right. Got plenty
There
of
we go.
time.
All right. Thanks so much.
All right, and then next up we have Catherine Tricky. So Catherine, if you want to start sharing your screen.
Absolutely. Can you hear me okay?
Yes, we can.
All right, perfect.
Oh, well, there's my dog. So next up we have Catherine Tricky, who's going to give us her presentation on web application design for the Maine Cooperative Snow Survey.
All right. Hello, my name is Katie Tricky, and today I'll be discussing my proposal of a web application design for the Maine Cooperative Snow Survey. I'll begin my discussion by talking about relevant background information, the goals and objectives of my proposal, the proposed methodology, challenges and limitations that I may face, anticipated results, which will include a preview of a user interface prototype, and finally conclude with my project timeline. So let's dive in. The Maine Cooperative Snow Survey collects data about snowpack depth, density, and water content from late winter and early spring. when the dangers of flooding in Maine's rivers and streams is greatest. The first maps for this snow survey were created about 20 years ago, and they were not designed for the web because at that time, the technology to create interactive web applications did not exist. Today, this effort is coordinated between 16 different organizations who are involved in data collection, and data analysis is performed by the US Geological Survey and Maine Geological Survey. These results are then displayed in static maps and used by other organizations to make informed decisions for emergency management purposes. For example, the National Weather Service uses these maps for decision making when preparing flood potential statements and running flood forecast models. The current workflow produces static maps of the data that is collected by the 16 organizations within a 3-day time frame. This is crucial for delivering timely and accurate data because snowpack can sometimes change on a daily or even hourly basis. This process begins with cooperative data collection and then goes through the steps of quality assurance and quality control check. Next, all the data is sent to the Maine Geological Survey, or MGIS. And finally, MGIS combines this data into published static maps. The primary purpose of the snow survey and its maps are for flood forecasting, which is the reason why they are published so quickly. If you think about it, the longer it takes to publish the data after it has been collected, then the more out of date these static maps become. This image is one example of a static map that is produced by the snow survey, and it shows equivalent water content in snowpack from April 7th to 8th in 2014. This data is also used to provide a map comparison feature shown on the left, which compares 2 different survey dates and years of water content data, as well as a graph that shows historical record mean water content by selected survey site, which is shown on the right. To access these static maps, a user must navigate to the Maine Cooperative Snow Survey website. You then have to select the desired survey year, survey date, and the map or file. As you may see, this user interface appears to be a bit clunky for some viewers, but you will eventually find the map you're looking for. In addition, these maps are also static, which limits the user's ability for data exploration, such as trying to find data collected for a specific survey site. In this current user interface, this task may not be possible for a public user who is not familiar with this website. So, can anything be done to improve the display of this snow survey data? The goals and objectives of my proposal are to utilize geovisualization to transform Maine Cooperative Snow Survey's snowpack depth, water content, and density data from static maps into an interactive web application. The resulting beta application would enhance user exploration of the data by having a more engaging user interface and prompt questions that have yet to be asked. In addition, this application usability would be enhanced by incorporating user-centered design methods into the GIS design process. My final objective is to meet the 3-day timeframe required for creating these maps on a recurring basis, which will be explored using programmatic automation. The proposed methodology is to follow the process of GIS design while incorporating user-centered design methods to ensure each stage considers the target audience. These GIS design stages include need assessment, concept development with low fidelity prototypes, prototyping with a high fidelity prototype, proposed implementation, and a design evaluation, which occurs at the end of each stage. For this project, there are 3 low fidelity prototypes, which contain a black and white color scheme to encourage the focus to remain on the user interface components and how they work. These prototypes are meant to be rough mock-ups of the beta application and do not contain interactivity, detailed visuals, and detailed content. The high-fidelity prototype created for this project is designed to match the beta application more closely. The purpose of this prototype is to look more realistic by the inclusion of interactive elements, more detailed visuals with color, and having all content that would appear in the beta design. Examples of this include tooltips for icons, which show explanatory text when a user hovers their mouse over an icon, and drop-down menus for selecting a specific survey date, survey year, and snowpack data type. All prototype creation in the concept development and prototyping stage include receiving feedback from the target audience. This feedback will be prioritized based on what is reasonable for the project timeline. And the remaining feedback will become future work after this project has concluded. The primary target audience for this beta application is the Riverflow Advisory Commission, because they view the snow survey maps on a regular basis. The Maine Geological Survey, or MGS, is also part of the primary audience because they are maintaining this product after it has been created. The secondary target audience includes any of the 16 organizations who are involved in snow survey data collection. The options for data retrieval include accessing it through the Maine Snow Survey Data ArcGIS Hub website as either an ArcGIS REST API, data download, or exporting it from the MGIS SQL Server database. Further research is needed to explore the programmatic automation to determine the best approach for meeting the required 3-day timeframe to create these maps on a recurring basis. In addition, there are 3 expected tasks a user plans to accomplish with this web application. These include exploring snowpack depth, water content, and density data by a single map view based on the survey year and date. Having the ability to compare maps of different survey years, dates, and snowpack data types by a map compare view, and having the ability to graphically view historical record mean water content of selected survey sites. After the beta application is created, it will be given to the Maine Geological Survey, or MGS, for continued maintenance and support. This decision was made because MGS is the primary source for sharing the final data collected for the Maine Cooperative Snow Survey. Therefore, the potential challenges of this proposal are the unknown MGS requirements and standards for evaluating alternative capabilities for this design. These include hosting platform, code structure, data connectors, and publishing requirements. Currently, MGS uses Esri products, such as ArcGIS Hub, for publicly sharing the snow survey dataset, and it is likely that the hosting platform would also be Esri. Regarding the potential challenges for code structure, data connectors, and publishing requirements, the discovery of these will be based on input from MGS and exploring documentation that addresses these limitations. The anticipated results of this proposal are a beta web application that is built using Esri's ArcGIS API for JavaScript, which incorporates front-end development tools to provide an intuitively designed user interface. In addition, this application will include programmatic automation to meet the 3-day timeframe requirement for publishing the snow survey maps on a recurring basis. Lastly, there is potential for this beta product to be publicly available on the Maine Cooperative Snow Survey website. Next, I'm going to show you a brief preview of the proposed low-fidelity prototype, which was created with Adobe XD. This is a user interface prototype, and the data will be added to it, but currently it is meant to give you an idea of how the application will work. As a reminder, This beta web application is being built using the ArcGIS API for JavaScript, and further research is needed to determine the best front-end development tools to incorporate into it. A few examples of these tools are Bootstrap, jQuery, or Vue. All right, here we go. It begins with a splash window that shows the application name, which is called Main Cooperative Snow Survey Data Explorer, and shows the user how to select a survey date, survey year, and snowpack data type. Upon closing this window, the full application prototype is revealed. There are 3 data exploration tabs located in the upper left corner of the app, which are titled Map, Graph, and Map Compare. Each tab contains interactive features, such as tooltips for the different icons shown, which appear when a user hovers their mouse cursor over a specific icon. This view of the Map tab shows all icon tooltips available in this prototype. In the top left corner of each tab, heading text is shown. In the Map tab, this text reads, "A map from April 21st, 2021, showing snowpack water content." The date text of April 21st has a drop-down arrow, which upon clicking enables the user to switch to their preferred date. The same functionality is applied to the year text. So I could change this text from 2021 to 2019. Lastly, the upper right-hand corner of this prototype contains 2 buttons. The button on the left is titled Overview, and when clicked, it displays a splash window of overview text. The button on the right is titled Search for a Location and would enable a user to search for a physical address. I'd like to wrap this prototype preview up with a quote I found that emphasizes the importance of prototyping. Kara Pernice stated that, "Ripping up code is very expensive. Ripping up a prototype is not." It helps reiterate the effectiveness of using prototypes for designing web applications before even diving into writing the code. All right, now on to my project timeline to conclude this discussion. I plan to work on the needs assessment stage from now until February of next year. I will then spend 3 months after that working on the concept development and prototyping stages. And then from June until September, I plan to complete the implementation stage. This project will conclude in October with my capstone presentation at either the online virtual Penn State conference or the Fall New York conference, which is hosted by the Northeast Arc Users Group. Thank you for their time. And are there any questions?
All right, Catherine, thank you very much for your presentation. Wait and see if we have any folks ask a question. While we're waiting, I was wondering in your user testing group, if you were going to divide your folks into any kind of classifications in terms of expertise or preference on using the site for a certain function.
I do have a proposed group for user testing, but all of this is going to be done informally. Ideally, because it will be based on the project scope and in order to meet the project timeline. But ideally, yes, I would pull members from the public, members from the primary target audience, which is the River Flow Advisory Commission, as well as the main geological survey cooperators, as they will be the main users of the app. In addition, I plan to avoid using any kind of technical jargon in the application itself. So if a public user stumbles upon it, then they will hopefully be able to interpret the information and find what they're looking for.
All right, well, thanks. Looks like you have a question in the chat.
Okay. Have you considered a mobile version, or would that not work with your data? I have considered a mobile version, but that may be outside the scope of this project. Currently, my focus is on a desktop version, but I have also dabbled with prototyping a mobile version as well. Next question is, do you have the connections within MGS needed to resolve the unknowns? Yes. I currently work at the U.S. Geological Survey, and we have a group in our center that works with the main Geological Survey as well as in the Snow Survey. They're actually part of the data collection effort. And so I have already begun conversations with them, and they seem excited about this project and are happy to work with me to troubleshoot some of their issues, as well as possibly assist with the creation of the static maps, because my idea is to replicate this into a more interactive form, which means I want to present the data in the same way so the people who need it can find the information they're looking for.
All right, Catherine, if you could put your email contact in the chat window, so if anyone wants to contact you afterwards, they can and ask you a question.
Absolutely.
And thanks again for your excellent presentation. And next up, we'll have a presentation from Andrew Bagnera. So Andrew, if you want to get your screen sharing going.
Okay, let's see.
We see your presentation and we can hear you. So whenever you're ready, go ahead and start.
Okay. Morning, everyone. My name is Andrew Bagnera, and this is my capstone proposal presentation. And it's titled Utilizing LiDAR and Aerial Imagery to Identify Vernal Pool Edges in an Upland Habitat Analysis. And my advisor for this project has been Karen Schuckman. Okay, so it's pertinent to this presentation for me to talk a little bit about my background and how it relates to my proposal idea. After my undergrad degree, I began working in Massachusetts, specifically in Barnstable County, which you may know as Cape Cod. I began here as an environmental AmeriCorps member, learning about the biodiversity and fragile habitats in this unique part of the country. I would eventually become a land manager for 2 town-based conservation groups, in which one of my major responsibilities was wetland habitat management. It was here that I was first introduced to the term vernal pool and learned of their significance in the realm of conservation and how they are threatened due to development disturbances. The state of Massachusetts is actually one of the few that has legal protection for vernal pools if certified and delegated by local governments. So I work to identify and certify pools as part of my management duties. The pools could sometimes be difficult to access or even notice due to their hydro periods and size, but I was able to certify a handful of pools for protection while there. And I have a few pictures. The one on the left is a wood frog, which is a species that requires vernal pool habitat to reproduce. And then the picture on the right is me doing some vernal pool inspections out in Massachusetts. Okay, now that I have more skills in GIS and remote sensing since doing the Penn State GIS program, I thought returning to these habitats for a capstone project idea was a worthy cause. That's why I've chosen to have my study area here in Cape Cod. The image here shows the boundary of Cape Cod, Massachusetts, and the exact study area I'll be using will be determined based on the size of data and computing resources. I'll note here that Cape Cod and Barnstable County, I use them interchangeably, and both are referring to the pale, almost hook shape of Massachusetts there. All right, here are the main goals and objectives I have for this project. I'm going to utilize new remote sensing and LiDAR technologies to identify certified and potential vernal pools in Cape Cod. I'll visualize hydro edge boundaries from imagery and or LiDAR data collected during leaf off conditions. And leaf off conditions is when water bodies are at their fullest throughout the year. Then I'll compare hydro edges to vernal pool obligate species, migration metrics, and state regulated 100-foot upland buffer. and to determine the level of developmental disturbances within these buffer zones. Okay, at this point, you may or may not be familiar with the term vernal pool or vernal pond, but it would be surprising if we all had the same definition. In research, I had found that while mostly similar, vernal pools were described differently from study to study. The first definition, taken from a forest management guideline article on vernal pools, defines them as small, usually less than an acre, seasonal wetlands that lack perennial inlet or outlet streams and have no permanent fish populations. The second definition, taken from a vernal pool LiDAR project, which I'll go into detail in the following slides, describes them as confined surface depressions with no permanent surface inflow or outflow with a total surface area larger than 50 square meters. And this definition is very much tailored to the type of analysis that they could confidently call a vernal pool based on their methods and results. And another definition, taken from the Vernal Pool Association, describes them as a contained basin depression lacking a permanent above ground outlet. In the Northeast, which is my study area, it fills with water with the rising water table of fall and winter, or with the meltwater and runoff of winter and spring. I have a few images here to help better understand what these pools look like, both of which are located on Cape Cod. The one on the left was taken in the town of Barnstable, and it's important to note a clear water edge in this image. In contrast, the image on the right shows a vernal pool, but one with much less uniformity in declaring the water's edge. These images were taken at a time when the depressions contained water, so most likely during winter, during those leaf-off conditions. During warmer months, these pools would most likely be dry, which is a key characteristic of a vernal pool. This creates a habitat safe for certain breeding species who rely on these habitats to survive, because there would be no fish predation in water, in a water body like this. So why are they important and the focus of my study? These habitats are critical breeding habitat for those obligate and facultative species due to the uniqueness of the changing hydro period, which is when they dry in the summer and they are full of water in the winter, and upland habitat in which these species spend 95% of their year in. They're also important in their role as stepping stones to other water habitats. A study done in Maine on wetland simulations concluded that the loss of small wetlands like vernal pools poses a significant risk of species extinction and the erosion of their ability to disperse to new areas. Also, development has contributed heavily to much of the habitat loss over the years. According to a study by Jamie King on the paper Loss of Diversity as a Consequence of Habitat Destruction in California's Vernal Pools, California's Central Valley is estimated to have lost anywhere from 50 to 85% of vernal pool habitat since settlement. Cape Cod has seen increases in development over the years to a lesser extent, but the importance of identifying these habitats remains. And this picture is of a fairy shrimp, which is one of the species that require vernal pool habitat to survive. The state of Massachusetts has a growing history in vernal pool management and study, and thus has a legally backed definition. From the Massachusetts Wetland Protection Act, vernal pool habitat means confined basin depressions, which at least in most years hold water for a minimum of 2 continuous months during the spring and summer, and which are free of adult fish populations, as well as the area within the 100 feet of the mean annual boundaries of such depressions to the extent that such habitat is within the area subject to protection. So that's talking about 100 feet beyond the water's edge that's also protected in the state of Massachusetts. So within that definition, we also have a big emphasis on indicator wildlife as a necessity for the habitat to be vernal. This leads me into the certification process in Massachusetts for vernal pools and the 2001 effort to identify potential vernal pools using aerial imagery. To become state recognized protected habitats, Massachusetts has set up a certification process through the Natural Heritage and Endangered Species Program, which identifies certain criteria needed to be met. This figure shows us some of the methods required through the state certification document. And it's showing us two methods here. One, you can use the obligate species as well as physical criteria proving that it's a body of water that dries out in the summer and not permanently flowing. Then the other is through various facultative amphibian species. We have more detailed information here on the various species Massachusetts has declared as obligate species for vernal pools. And from the certification guidelines, when I say obligate species, it means vertebrate and invertebrate species that require vernal pools for all or a portion of their life cycle and are unable to successfully complete their life cycle without vernal pools. So these listed species rely on these pools for survival in Massachusetts, including down here, we have the fairy shrimp and the wood frog, and spotted salamander, which I've seen firsthand in my own field surveys in Massachusetts. The history of vernal pool regulation in Massachusetts, it mainly falls into 4 pieces of legislation. Without boring you with the details of each, I'll just summarize some of the information provided by the Vernal Pool Association and the Wetlands Protection Act. For a pool to be protected under the Wetlands Protection Act, it must be a state certified pool, but pools may also gain protection through the other 3 acts listed. Local governments may also enact their own regulations for protection as well, while mostly adhering to the Wetlands Protection Act, which protects the pool and up to 100 feet upland from the water's edge. All right, I wanted to provide this image, which comes from a document called Protecting Vernal Pools by the Vernal Pool Association, to help illustrate what state regulations protect in a vernal pool habitat. This inner red circle shows the water's edge of a certified vernal pool full of water. And then that outer red ring represents the 100-foot line buffered from the water's edge. So when the state says vernal pool habitat, it's referring to the area within that outer 100-foot line. The 100-foot upland buffer designated by the state was established because it provided upland habitat for the breeding species that use the pool. But studies have shown that just 100 feet of upland protection can be insufficient in providing enough habitat for the upland migration ranges of some of the obligate species. The spotted salamander and wood frog are both listed as obligate species in the certification document, and shown in this image pulled from a document called Best Development Practices Conserving Pool Breeding Amphibians in Residential and Commercial Developments. As you can see, the spotted salamander migration distances range well beyond the 100-foot buffer, and the wood frog distances are far larger. I'll work to research more about these migration distances, but there seemed to be a big disparity, mind you, with expected reasons to be discussed in the next few slides. All right, so that same management document describes the habitat currently with the possibility of protection through the regulations as follows. In the spring, high densities of adult salamanders and frogs occupy the habitat immediately surrounding the pool. Similarly, in early summer and early fall, large numbers of recently emerged salamanders and frogs occupy the same habitat. This zone also maintains the water quality of the pool depression and provides a source of leaves, which constitute the base of the pool food web. And I've highlighted this 100-foot area here in yellow as well. Now let's look at the habitat described beyond 100 feet, which is beyond the 100 feet protected by the state. This area provides habitat for amphibians during the non-breeding season for foraging, dispersing, and hibernating. During the breeding seasons, adults migrate to pools through this zone. And I've highlighted again in yellow here. So adults are living and moving throughout this zone in breeding seasons, if allotted. Recommendations from the same document are to maintain shade, deep litter, and woody debris, as well as minimize disturbances to the floor. So with a bit of history and background of vernal pools in Massachusetts out of the way, let's look at the summary of the perceived problem. We do have state regulations implemented to protect vernal pools, which is fairly unique as most states do not have vernal pool regulations at this time. The size of protection does seem to be controversial though, as this alone does not seem to be enough to provide sufficient upland habitat to these breeding species. One argument that could and has been made though, is that the 100 feet is a compromise as it offers some upland protection without significantly hindering development throughout the state. That said, I want to offer up my themes going forward with my project. Things to think about. How protected are vernal pool upland habitats in Massachusetts based on the obligate species migration distances? Do current state regulations for certified vernal pools offer enough upland protection? And how does development affect available upland habitat? The scope of my project will be conducted in 2 phases. Phase 1 will be to identify vernal pool habitat, including upland zones for a study area in Barnstable County or Cape Cod. As of now, I do not have a specific study area because of unknown system limitations with large amounts of high resolution imagery. I'll plan to look into a specific town such as Falmouth, which has a good amount of existing data. If I need to go to a smaller study area though, because of those limitations, I will. Phase 2 will then be to determine how protected the upland habitats are with factors such as buildings and roads in a continuously developing environment. This is a brief outline of my proposed methodology, starting with phase 1. I'll start by identifying a study area in Cape Cod that exhibits good existing vernal pool data, as well as a diverse landscape of wetlands, forests, development, etc. Then I'll acquire existing LiDAR, high-res imagery, vernal pool, and other pertinent data, which most can be found on website MGIS. Existing recent methods of identifying vernal pools have involved both LiDAR and high-resolution imagery as a combination. So I plan to use a combination of both to initially identify depressions in the landscape that can be refined by using other data. One such intriguing LiDAR method from a study in Connecticut called an effective method for detecting potential woodland vernal pools using high-res LiDAR data and aerial imagery is something called a stochastic depression analysis. This method extracts polygons from a LiDAR digital elevation model, which can be used to represent the water's edge. The key aspect of imagery used in this phase will be high resolution 4-band imagery acquired during leaf off conditions. Because many vernal pools exist in forested areas, this type of imagery increases the likelihood of identifying vernal pool habitat, as these bodies of water may also be dried up during the summer. As a way to check for errors in my resulting polygons, I'll be using existing certified and potential vernal pool point data provided by the state. All right, once I have created vernal pool polygon layer for the study area, I will be creating buffers from the water's edge, representing both migration distances and the 100-foot protected zone, implying if the pool were certified, it would be protected within that 100-foot zone. The distances for migration zones will be designated after more research is done into the best representative distances for amphibians. From here, I plan to do an analysis of the amount of disturbance within these buffers to determine how much disturbance is occurring within the protected zones and how much is occurring in the migration zones. Of course, disturbances would need to be defined, but I am envisioning land cover that could be classified as buildings or pavement would qualify as disturbances, as they are defined that way in the best development practices article referenced earlier. So a little bit about this certified and potential vernal pool data. After the revisions of the Wetlands Protection Act to include vernal pool protection, the state of Massachusetts conducted an aerial imagery survey to identify potential vernal pools across the state. This was accomplished in 2001, and the methods were very of the time, which means they included interpretation of black and white 1 to 12,000 scale aerial photos under a stereograph to add three-dimensional viewing. And then interpreters determined bodies of water that would be worth giving the title of potential vernal pool, which it's been a great tool ever since to help guide folks in the field certifications. But the data set does also include points for certified pools as they come through the certification process. And these have been ground truthed and submitted to the state. So those do represent actual vernal pools. I plan to use this data set as a way to check my results for accuracy. It's important to note that my resulting polygons cannot be labeled as certified vernal pools, as there are no ground truth to them unless they are represented by one of those certified vernal pool points. These images were taken from a MassGIS data viewer and show the potential vernal pool and certified vernal pool points available in a town like Falmouth here. The certified being this blue star and the potential being this light blue bullseye. I'll also plan to use the above layers for my analysis in identifying and refining the depression polygons into potential vernal pools. LiDAR data will be accessed through USGS as a point cloud and has a 1 meter nominal point spacing collected from 2013 to 2014. The 4-band imagery tiles have a resolution of 15 centimeters and were collected during leaf off conditions, which is important. These are all available on MassGIS. The NHD water body dataset provides polygons of known bodies of water, which would be helpful in determining if the bodies identified in my analysis have inlets or outlets. This is also available on MassGIS. And the structures dataset is also available on MassGIS and consists of 2-dimensional roof outlines of buildings larger than 150 square feet. I'm also considering upland wetland data for Massachusetts. One example would be the National Wetlands Inventory Dataset created by U.S. Fish and Wildlife Service and has been updated as recent as 2020. This would provide more reference water bodies to compare my results to. This project will no doubt bring about some challenges that I will need to address. I foresee a few right now, including qualifying pool edges based on when the data was collected. And what I mean by that is I will need to look into various factors to qualify the water edge polygons, such as how much rainfall there was that year compared to others. It's possible the data used represents a time when pools were not at their maximum capacity or even mean capacity. As shown in the image below, the pool's edge can fluctuate. It can be full like that, or it could be dry. It depends on the time of year and when the imagery is looked at. Additionally, working with large data sets like high resolution imagery could pose a problem when processing on my personal computer. It is possible cloud solutions may need to be consulted to advance the project along. And a third challenge is determining which bodies of water would qualify as potential vernal pools as opposed to perennial wetlands. Through research of previously tried methods in other research projects, I'll utilize available data in a way that I believe best accomplishes this and document the methods as I go. I anticipate some meaningful results from this project that expand on research done by others in Massachusetts regarding vernal pool identification. The first of which will be a newly defined layer showing potential vernal pools in the study area. The potential vernal pool data, which is most readily available to the public in Massachusetts, was created in 2001, which is that image I showed you on the data slide. As we are now 20 years beyond then, newer, better techniques have been developed, and I plan to use them to create hopefully a more accurate potential vernal pool layer. I will also be creating habitat migration maps throughout the study area, which build upon just locating and identifying the pools. Here we'll be able to see areas that according to the guidelines, should be left undisturbed in such a way to promote healthy populations in these habitats. Statistics will then be a deliverable I plan to make part of this project, and that they will show how disturbed these different zones are, which will lead to some interesting discussion points regarding development on Cape Cod and the trade-off to vernal pool habitat loss. Lastly, I want to show a brief timeline of how I expect things to go from here. I'll start by downloading and analyzing the data a bit more before proceeding to pre-processing everything to make sure the data is compatible with each other. Then I will do the 2 phases of analysis before compiling results and discussion points. Then I plan to present at a conference, and the one planning right now is the ASPRS annual conference, which I believe is in March. And finally, I will deliver the report after feedback from the conference. Thank you so much for listening to my proposal. I hope you enjoyed the presentation as much as you're probably enjoying the picture of this spotted salamander. I hope you see the value in a project like this going forward, and I will now take questions.
All right, Andrew, thanks for that great presentation.
Thank you.
Looks like you already have a question in the chat window.
Let's see. So the question, are you familiar with the upcoming changes to the federal definition of a wetland, narrowing the definition? If so, will this change what is considered a vernal pool? I'd imagine the state's definition would still be used. I was not aware that there were federal changes coming to the definition, but that's definitely something I should look into and see. And I'll have to look and see if the state plans to do anything to change theirs as well, but I haven't heard anything about the state changing their definition, but that's something great I should look into. Thank you.
While we're waiting for other questions to pop up, I have a quick question. So I saw the map that you showed that outlined your study area with some of the vernal pool sites. And I was curious in your analysis, if you're going to stratify those points in any regard. I noticed some were, for example, really close to roads, and others were pretty distant from any what appeared to be human encroachment. I noticed the area was minimally urbanized. So I don't know if that matters a whole lot in the overall scheme of your project, but I was curious to know if you were going to, again, stratify your research area and data collection techniques according to some aspect of land use, land cover.
So I was planning to use those existing vernal pool points to check the accuracy of what my results yield when I do the LiDAR and aerial imagery. I suppose, what did you mean by stratify?
Well, if you're trying to assess the accuracy of the vernal pool habitat areas or some other aspect of ensuring accuracy of your delineation, maybe your accuracy is better in areas that are very remote from roads versus those areas that are closer to roads, those areas that are closer to buildings or human structures, those that are far away from structures.
Okay, I think I see what you're saying. I'll have to look more into that, stratifying them. I know that these points have given specific, buffers for error. And I think the potential ones have like 5 meters and the certified ones have 20 meters. I was planning to make buffers around those just to see if my polygons intersected them.
Yeah.
Yeah.
All right, there's a few more comments for you.
Okay. Let's see. I'm not sure if, okay, wait. Okay, next question. I'm not sure if Massachusetts GIS site has intensity imagery that can be made from LiDAR data, but that may assist with the 4-band imagery as well. That's a great point. I'll have to look and see. I don't remember seeing if they had that or not, but thank you, Jeremy. I'll look into that. Just a comment, I had to check for vernal pools on sites when I was a development review planner in California. They are unique habitats and also ones that many people are unfamiliar with. It's great you're pursuing a project that will help their protection. Well, thank you very much. Is it Adrian, I think? Yeah, it's something I'd never heard of them before I went to go work in Massachusetts. And they're very unique. Okay, Karen says intensity should be in the last point cloud data. Thank you, Karen.
Well, if there's no more questions, Andrew, if you want to put your contact info in the chat window, if someone wants to follow up question, that'd be great.
Okay.
And thank you again for your insightful presentation.
All right. Thank you. Thanks, everyone.
And then next up, Blake, if you want to go ahead and start sharing your screen.
Okay, I'll try to pick the correct screen. Can you hear me okay?
Loud and clear.
Great. And can you see that screen?
Not yet. Oh, there we go. There we go. Looks good.
Perfect. Okay, just make sure. Okay. So the title of my project is Geospatial Web App Development for the Center of Louisiana Studies Archive. The center is located at the local university in my hometown of Lafayette, Louisiana. The university is UL Lafayette, also known as the Raging Cajuns. The Center of Louisiana Studies Archive houses over 30,000 audio recordings, video recordings, and images, and these all pertain to Louisiana culture. When I say archive in this project, I'm referring to these resources in particular. The archive spans 87 years and includes both professionally produced and homemade recordings, mostly in French and English languages. And the center's goal is to preserve Louisiana cultural resources for future generations. So the area of Louisiana is known especially for Cajun music, this area. That's a musical style formed by the blending of Western French, Nova Scotian, Native American, Creole, and Spanish also, styles of music. The Cajun people themselves have a history of leaving countries due to religious persecution. And this map shows the diversity of the places that the Cajuns have lived. Most of the current Cajuns, including myself, are concentrated in South Louisiana. The archives are also used by local and international researchers. for both professional and personal projects. And also many of my friends who are local Cajun musicians use the archives because a lot of these songs were passed down by word. They weren't recorded. So there are very few recordings actually in existence. So the musicians actually go to the center on campus and listen to old recordings to learn songs that were forgotten and haven't been played for decades. The Cajun culture and the music is directly tied to food and local Louisiana environment. And both of these things have influenced Louisiana culture since it was first settled. These are some examples of the pictures, the photographs held in the archive. This is a picture of Alan Lomax in Louisiana. He was a famous ethnomusicologist, and he traveled to Louisiana in 1934 to make recordings of local French songs and some English songs also. And these recordings are kept both at the center and also at the Library of Congress in the Alan Lomax installation there. So what's the current problem that they have with the way they currently display their data? So the current data, the way it's displayed on a website is not interactive, and it was conveyed to me that the users didn't find it interesting because it's only in a text format. The current database for the archive is hosted on the Drupal platform. And if you're not familiar, it's a platform used by many universities. It's an open source content management software used to make and manage websites. And the website currently is accessed through the public university's website. The data is. And what's important is they wanted a geospatial component to go along with their text-only data to make it more interesting. And by showing this, a lot of the people who access the website are local citizens, and who go to the archives also are mostly probably 90% local. So it does help with the preservation of Cajun culture to make this data more interactive and viewable, especially to younger people who are used to, iPhone apps and everything like that. So through these connections, the users can begin to explore their local traditions. They're going to understand cultural links, excuse me, in a spatial context, and hopefully they'll pursue interest in the Cajun culture. Here is an example of the current public-facing user interface found on the center's website. For this example, I searched for the word fiddle, and the results were populated only as text, and the accession number is also given, which is currently the only way you can bring that accession number to the library, to the center, and access the recordings that way. So it's pretty old school how they're doing that. I had a series of meetings with the staff of the center and also discussed with my advisor, and a few general and specific goals were outlined by the center. The first general goal is to develop a geospatial archive data set system. And that makes the current archive data more interactive and hopefully interesting by integrating geospatial components into the final product. And the second general goal is for the end product to be a long-lasting system with little staff maintenance needed. And you'll see later in my presentation, I've chosen applications and development environments that can be used for people who have little to no coding experience, because they're going to take this over basically when I'm done with the project. Some specific goals. The first specific goal was to export the current database, and then cleanup and error correction will be performed on the exported database. After that, the database will be uploaded to ArcGIS Online, and then it will take the place of their old database. So this new ArcGIS online database will be the standard database that they interact with and that my applications pull the data from. And finally, this uploaded data will need to be geocoded and saved as a hosted feature class on ArcGIS Online. The second specific goal is the creation of a data entry web application so that the center staff can update the archive database, which is in the form of that hosted feature class previously mentioned. The third goal is the creation of an archive data mapping and querying web application. And this is going to perform simple and also complex queries on the archive data and display the results as it was displayed in text, but also in geospatial forms, which will hopefully be more interactive and interesting to the users. And the last goal that the center had was the creation of a website to hold and link all these applications together. So choice of development environment is important, and there are many choices for web mapping software providers. And this has to be made early in the process because of the amount of work to develop the multiple apps. So many universities, including UL Lafayette, have a recurring GIS software subscription with Esri. And this subscription comes with features to develop web applications that are hosted on their ArcGIS online environment. I did look at other potential free options and some other paid options, but the Esri environment seems to be what they want to go with because they're already paying for that and basically not using any of their resources provided with that subscription right now. And also scalability was a huge part of this. The website does get quite a few hits, and we wanted it to be scalable so many users can hit it and it wouldn't crash or have any server issues. There were discussions early on about hosting it locally and having a company in town host it and develop it using the JavaScript API, but the system that Esri provides integrated and the scalability just made much more sense to go this route. The John Hopkins COVID-19 dashboard actually demonstrated the scalability of ArcGIS Online. And one fact I have here is as of July 2020, the dashboard site was getting between 3 and 4.5 billion requests per month. And also Esri has published a best practices article to show developers how to build scalability into the apps that they want to develop. The proposed methodology for this project is going to involve multiple web applications all working together, lots of moving parts, and interacting with what I refer to as a central database, which is basically the main hosted feature class. There are going to be 3 separate ArcGIS online applications. There's also going to be an automatic backup of the hosted feature class that I will also develop. And this project is a good fit for my capstone because I wanted to attempt multiple app development, especially after taking some of the coding classes at Penn State. And I'll also be able to pursue my interest in Python by writing backup automation and hopefully data cleanup scripts. So due to the complexity of all the components interacting, I developed this flow chart. And this chart displays the flow of data through the various components of the application suite. The phase 1 at the top left portion of the flow chart deals with data that has already been recorded to the old database. And to the top right, the phase 2 portion is where new data records will be added to the ArcGIS online by the staff themselves. So they'll receive data and they'll use the data entry web application to update the feature class. Phase 1, more in detail. So the previously recorded data is currently being held in a MySQL database inside the university's Drupal content management system. And the the university webmaster has agreed to export this database either in an Excel or a CSV format. Just an example of how big the database is. Currently, there are almost 9,000 rows and there are 25 fields. And with their 30,000 records constantly growing, this database will eventually get even larger. So there are fields that were entered using typed in entries instead of drop down entries. So this does pose a problem for consistency throughout the data. So a big part of the beginning of this project will involve cleaning up the data. I'm currently learning how to use Python libraries such as pandas to do some of that heavy lifting in the data cleanup department. After the data cleaning process is complete, the data will be uploaded to ArcGIS Online as a hosted feature layer. And the last step in data phase 1 is the geocoding of the uploaded data. And luckily ArcGIS Online has that ability to convert addresses, town names to XY coordinates and append these results to the existing record in the database. So right now there is the only spatial field has random entries. Sometimes it's a parish, which is a county. If you're not familiar with the way Louisiana terms their counties, there's parishes, there's towns. Sometimes the entry is just a state or a road. So I'm gonna have to sort all that out in the data cleaning portion of this project. So on to data phase 2. This is going to require the only input from the center staff within the whole data flow diagram. Following the initial upload of the center's current database in ArcGIS Online, new data that needs to be recorded in a database will be continually received. The local people are finding video recordings and audio recordings, cassettes, in their attic or estate sales, and these are just brought to the center and they convert them to digital form and add them to the database. Okay, sorry about that. The first application that will be created in the archive data system is a data entry web application. And I'm going to use Esri's web app builder for that. That's a product they use that's part of the online ArcGIS Online subscription. And one of the built-in widgets that will provide data entry ability to the staff is the edit widget. Once the data is hosted on ArcGIS Online, the edit widget, which I'll insert into one of my web applications, can append data to the previously uploaded data. So it can actually add data to the main feature class that is feeding all the applications. And so this is a working prototype that I developed, and this was just developed to show the center what's possible. The edit widget was used to create the feature editor in the top left portion of the picture. After the data entry is complete, the changes will be automatically saved to the hosted feature service. Now on to backup. So why is backup needed? Well, this won't be anyone's full-time job at the center to enter data. They already do this, but they also present at conferences and teach classes. So we need to back up the current data that exists and their progress through entering, so they won't lose many hours basically. And also many of the data entry people are going to be interns and students, which in my experience tend to have a little more errors entered when doing data entry. So a weekly backup will be scheduled, and the Python programming language will be used to code the backup in the ArcGIS Online environment. And I'm going to do that using ArcGIS Notebooks, which is a web-based interface provided by Esri, and it can run Python scripts in ArcGIS Online. In addition to creating notebooks, the script also needs to run weekly without any user input. Again, we don't want the center to have to do more tasks than they need to do. So luckily this year, Esri released the ability to run schedule mode in ArcGIS notebooks. And this is going to allow the script to be run on a schedule without any user input. The final script will save the current version of the hosted feature layer within ArcGIS Online. One of the center's primary goals is to have a web application that can search through their archive data using both simple and complex queries. This will be the main application that the actual website visitors interact with to explore the data. And the results of these queries will just be displayed as points on a map with an associated attribute table. Again, ArcGIS Web App Builder will be used to create this second web application. And the previously created feature class will be the data source for this application, once again, feeding all the other apps. The primary categories that the center needs to, in their query searches, were expressed to me as location, recording date, and language, which is mostly in French or English. The query widget built into Web App Builder is going to allow the app creator, myself, to select a data source. The primary data source will be the archive feature class created from the center's data. This is an example of a web app prototype of the primary query fields that the center has expressed that they wanted included in this. You see on the left, you have a choice of location, recording date, and language. And on the right side, there are drop-down options for French or English. So far, the records I've looked at, those are the only two languages, but I'll expand that if there are any other entries. And then when you search for that, when you query that, after it's been executed, the web application will return results as seen here in the form of points on a map, reflecting the location of each result, and text on the right side of the positive values that meet the requirements of the expression you just ran. And when you click on the result, it will zoom in, and there's a pop-up associated with that point, which contains some of the same data, also contains links. That's something we might be developing in the future. So a lot of the material they have, there are different copyright laws, so they can't just release everything. So if there's a YouTube link with the same video, or if somebody says they can put their recordings online, these links will be associated with that on the university's local server. So it'll be running from another website. And the final portion of this will be the actual website itself. And luckily, Esri has a tool called Experience Builder. And that tool offers the same, or many advantages anyway, of Web App Builder, but it includes the ability to create fully interactive geospatial and non-geospatial websites. In fact, Experience Builder can work in conjunction with Web App Builder and Story Maps, so that I can create a very professional web page with my applications, and also have a space for future story maps that the center wants to develop. This Experience Builder was built using React, which is a library for JavaScript used for creating user interfaces. It also uses TypeScript for widget development. And Web App Builder runs on the ArcGIS API for JavaScript version 3. Experience Builder uses the newer version 4. So eventually Web App Builder will be retired. So that also influenced the choice of using Experience Builder. Certain widgets are not yet available with Experience Builder. One solution I found to get some of the functionality that I needed is to use the embed widget to link previously created web applications made in Web App Builder onto the more modern Experience Builder interface. And one side note, besides supporting the embedding of a URL or an app, you can actually embed your own HTML, CSS, and JavaScript code into the site. So that's going to allow developers to increase functionality beyond what the basic widgets offer out of the box. And that's something I might explore if they want any functionality that I can't build using the WYSIWYG interface. This is a prototype website that was developed using Experience Builder, just to show them the possibilities. The links to you can see the links to the archive data querying web application, and also future story maps are provided. And this would be the homepage. And as you scroll down, this is just to show the possibility of embedding web applications on the left, and also embedding a story map directly into the web page, which includes a YouTube link built in also. And that's what's nice about Experience Builder. It's basically drag and drop, and everything works if you built things in other Esri environments. So it's pretty nice. The project timeline. So this month and next month, I'm going to be having meetings with the center on campus and starting data cleanup. I've actually just received the export of the database in a CSV format, so I'm going to get started on that. In February is the main application development time. I'm also going to be working on the Python backup using the notebooks on ArcGIS Online. And March will be another meeting, and I'm going to make some changes based on any feedback that they give me. And I'm going to start the Experience Builder website development, which is going to join all my previously created applications together in one website. April, another meeting to review, and I'm going to make changes based on that feedback, and those are mostly going to be for the website itself. May, they have a semi-hard deadline of May for the final meeting, and they would like by the end of May to have their data and applications published. And also I would need to schedule the Python backup script to run. And that does consume credits to run those scripts, but it's very little credits, and they're not using any of their credits right now. So this whole project will cost them no extra money, basically. And I will present at a conference. It's to be determined right now because I've just started a new job, a GIS job, and the flexibility is slowly opening up. So I will have to check with them and the conference schedule, and also my advisor to see what works out for everyone, basically. And the results. So the original problem that the center had that they approached me with was the public access of their data was seen as pretty uninspiring in its current strictly text format. So through the development of this data system, this data that is vital to the preservation of Cajun culture and my own culture will be more interactive and viewable in a geospatial web mapping environment. And the goal of this project is to allow users to better understand this data and hopefully observe spatial connections that right now are buried in the text data output, basically. And through these connections, users can explore their local traditions, hopefully understand cultural links in a spatial context. And the main goal is for people to pursue interest in Cajun culture, because the center is publicly funded by people, and there's a big movement in Lafayette, Louisiana to get younger people interested in Cajun culture, so the language and the music doesn't just die out. And last, I anticipate the choice of one geospatial web application provider, Esri in this case. It really will enable a path for the data system to function well into the future. Like I said, once I develop this, I probably won't be around to update it anymore. And so I'm going to help them out with learning some of the interface and how to change things and update things. So that's what's nice about Esri tools. Everything pretty much works together, and with a little study, I think anybody can learn how to do some basic functions. And that is the end of my slideshow.
All right, Blake, thanks for that interesting presentation. Great to see that you're trying to connect that database with more people.
Yeah, thank you.
Get the Cajun culture out there. I know I've been a fan of the Balfour Brothers for many years.
Oh, that's great. Yeah.
Yeah. While we're waiting for a question to come up, I do have a comment that maybe you can give some thought to.
Mm-hmm.
I know you're somewhat limited by the technology
Yes.
and time, always time.
Right.
But I've seen these kinds of platforms where you have the point, you click on the point, and then you see this basic table of information.
Mm-hmm.
Is there any thought or possibilities to make that information more graphic, more cartographic, rather than just having people sort through what could be dozens of pieces of text?
Like as far as different symbologies to represent on the
Well,
map?
either symbologies or different kinds of graphics. Instead of a map, have, I don't know, a histogram. I don't know what all kind of data you have available
Yeah.
to you, but to make it more of a visual representation than just tables of text with just a dot on a map.
Yeah, that's a good point. I've actually recently been looking. So it seems like every few weeks, Esri updates Experience Builder with more features. And they do have you can integrate dashboards into it and have graphical representations of the data itself. So I'm going to present that to the center. Basically, they kind of gave me rule over everything. It's whatever I want to present to them. So yeah, that's definitely something I want to look into, to display the data in a different context where, rather than just points on a map, graphs and histograms. And I definitely want to go into that route.
Well, I'll be anxious to see your 596B presentation then.
Great, thank you.
Looks like you've got a lot of questions there. So
okay, let's see. So Adrian says, great to see you. This is an ambitious project, but also one that can be very valuable to the community. As a fellow Cajun, I applaud your efforts to improve the important resources for preserving the culture. Good support, sounds like you have. All right, thank you, Adrian. Another question, will you be using focus groups or some other methods to reach out to the general public, non-university users, to help you with design feedback? Yes, I've already loosely coordinated a group of friends who have no idea about GIS or anything to try out. And I'm going to use that feedback and present that to the center. And then their plan is to have a group of students come in and test out some of the prototypes to use and give feedback to me based on that, because that's really important, where it's not just geospatial people accessing this, has to be visual first and understandable from people from many backgrounds. Let's see. So Jeremy, I know Jeremy, he lives in Baton Rouge. I appreciate your work. Thank you. One more quick note, Louis Michaud, that was listed on one of your slides, is my cousin. Great. I know Louis Michaud, he's a great fiddler. Thank you very much. Are there any other questions?
all right. So Blake, if you want to put your email in the chat, folks can follow up with you.
All right, I'll do that right now. There you go. Thank you very much, everyone.
Thank you. Next up, we have Matt Price. Matt, if you want to go ahead and start sharing your screen.
Right on. Hello, everyone. All right, hello everyone. Can you guys see my presentation all right?
We can see and hear you, so take it whenever you're ready.
Awesome. All right. Well, hello everyone. My name is Matthew Price. I'm here to present my proposal for my capstone, which is the wildfire vulnerability assessment for the Marin County within the Bay Area of California. Now, just to start off, I would like to note the study area of my research project, and that is the Marin County. Now, the Marin County within the Bay Area borders the Pacific Ocean and the Bay, and it consists of fragmented forests, native to non-native shrubland, cropland, and developed land. In general, it houses national parks such as the John Muir Park and state parks such as the Mount Tamalpais State Park. Now, in general, the Western US forests are dominated by high severity fires, mixed together with about 45% of low severity fires. And that is generally the topic that we're going to be going into for this presentation. Now, in general background research on this topic, I went to 4 different topics: local government, national environment, and the fire management of that environment. Now, the Marin County local government has a well-developed wildfire notification system used in website platforms such as FireSafe Marin, Alert Marin. These platforms are also conveniently available on mobile to tablet platforms. Now, what these websites do is that they provide evacuation maps outlining routes and evacuation locations for civilians. This also is shows different zones that the town is split into to kind of organize areas that firefighters can go into if there are fires there. Now, the wildfire warnings have 3 different statuses. One being evacuation order, which means leave now. Evacuation warning, which means you have time to leave, but eventually you should be leaving. And shelter in place. Now, shelter in place has 3 different definitions. One being unnecessary to move, one being too dangerous to move, and the other one is just unnecessary. Now, the local government, to speed things along for everyone, they provide a checklist that spreads around different topics such as communications, on-person items, general things you need to do for evacuations, things to do inside the house to outside the house, even your pets. And this checklist is given throughout the website to be conveniently accessed by the public. Now, to generally, as an overview for the whole county, the entire county is monitored by 6 stations that are responsible for wildfire prevention and protection. Now, these 6 stations are responsible for 340,000 acres of federal, state to local and private owned land. These stations are supported by a vast network of fire lookouts, a 24/7 camera fire detection system, fire engines, rescue vehicles, water rescue vehicles, and ambulances. This is also to note that various agencies within the Bay Area support fire department rescue operations with their own proprietary water rescue vehicles. Now, to bring the scope back out a bit more broad, the national government has various agencies that monitor the nation for wildfire incidences. Those being the Fire Information for Resource Management System, or FIRMS, National Wildfire Coordination Group, the U.S. Fire Administration, and the Federal Emergency Management Agency, or FEMA. Now, FEMA has their own proprietary analysis for the entire nation. As you can see on the right-hand side of the slide, you can see their own proprietary mapping web tool that denotes the overall risk for the Marin County. Now, the national risk analysis, national risk index, has 3 different levels of detail. One being the census blocks, census tract, and the county view. Now, to put into a medium view and medium detail, I'll put into census tract view for you guys in the picture. Now, the national risk index has 3 different components that average into this overall risk, and those being expected annual loss, social vulnerability, and community resilience. Now, I would like to note that the NRI does not consider the intricate economical and physical interdependencies of the geographical region when they consider this analysis. As you can see on the slide, each different component has varying levels of scores for each component within the area for each district. Now, these three components are inputted into an equation, as you can see in the bottom left-hand side, expected annual loss times social vulnerability times 1 divided by community resilience. This is equaled into the overall risk, as you can see in the top left-hand corner. Now, the natural environment of Marin County consists of, again, forests, shrubland, cropland, developed land. But we are kind of focused on the forested areas since this topic is wildfire instances. Now, recent research from proceedings of the National Academy of Sciences of the United States note that wildfires are now reaching what were usually wetter elevations. As you can see in the model in the bottom right-hand corner, in 1984, wildfires were kept at a relatively lower elevation due to a water barrier that was existent during that time. Now, due to climate change affecting our surface temperatures, say in 2017, that water barrier has been diminished, and wildfires have then encroached upslope to the peaks of the mountains. Now, what that does is that it creates burn scars, leaving areas devoid of trees and stands. And that in itself affects the snow melt that gathers along the peaks of the mountains. Now, the snow melt since 1984 is now evaporating at a faster rate than normal. And what that does is that it affects our own quality of water and quantity of water that reaches our own reservoirs in our local areas. Now, in general, I'm separating the elevations of the area of the forested areas into two different categories. High elevations, which are susceptible to high severity fires, and their key controllers being extreme drought, high winds, and local influences such as topography. And the next category is low elevations, which is susceptible to low severity fires. And those key controllers are ignition patterns, vegetation structure, and fuel amounts. Now, these key controlling factors are separated into each category and labeled non-amenable to amenable. Now, the low severity fire key controlling factors are amenable to human interventions and thus can be applied to new practices of fire management. The current practices that are used today are mechanical thinning methods used by the forestry industry. Now, as you can see in the model, in the top left-hand corner, you'll see a forestscape that has not been touched by the mechanical thinning practices versus the bottom right, which is heavily thinned forestscape. Now, the mechanical thinning by definition is the removal of trees and stands in strips and rows. Now, the impacts of that current practice creates byproduct surface fuels of unmerchantable wood, such as bark, chopped woods and limbs, stuff that cannot be sold to the public. Now, what the current practice of the removal of trees does is that it opens up tree canopy, giving sunlight penetration leeway to reach the ground, and that in itself generates vegetation growth. But that vegetation growth supports non-native plant species, which are by coincidence highly flammable. All in all, it increases fire frequencies. As an overview of the entire practice of mechanical thinning, it's an efficient way to go about things for forestry as a goal of economic and environmental stability. To manage the wildfire occurrences of the housing structures versus forested land, the government has created the Wildland Urban Interface, or the UE, which gives way to the home ignition zone, or the HIS, if you would. Now, the WUI is used by the government as a way to organize and strategically plan housing development, and it comprises of 3 different components: human presence, wildland vegetation, and the distance that represents the potential for effects. This is used with the home ignition zone, which is a barrier about 30 to 60 meters in length. As you can see in the model in the top left-hand corner, you can see the HIS in relation to the forest and housing structures. Now, each homeowner should be using the home ignition zone if they are in rural environments, and needs to treat the forested areas around their house within 60 to 30 meters. Now, both of these models are supported and actually encouraged to be used by the Healthy Forest Initiative, put forth in 2002, and the Healthy Forest Restoration Act, put forth in 2003. Pros and cons of both of these practices are thus: pros being the offset of operational costs of the logging industry is an efficient way of going about their logging functions. Fire suppression methods and the current practices of mechanical thinning is well suited to the dry and fire-prone forestscapes that we have, and it has a long history of successful fire management. Nevertheless, it has been historically used for controlling fire behavior and fire spread. Nevertheless, the UE has shown to reduce true costs of housing development and has been used as a valuable resource for strategic development of houses versus the forest and natural vegetation landscape. Now, cons to both of these practices are that since 1984, they have not adapted to our own climate change environments. Nevertheless, they create byproduct surface fuels, which pose a greater risk to lives and homes to the public. And I would like to note that since the housing crisis has happened, the UE's housing rate has been unchecked and has continued to grow and is still growing today. Having said that, this fact contributes the UE as a major factor to wildfire occurrences and costs. Nevertheless, both practices support non-native plant species, which are again highly flammable, encouraging more wildfires to happen. Now, what does all of this point out? It points out that the current policies of fire management do not recognize the cultural, environmental, and economic dimensions wildfire has to the Marin County. Now, beneficial strategies put forth, such as prescribed burning methods, are not radical. They're not new. They're not just made up in the recent decades. They have been used for centuries by Native Americans, using methods such as slash and burn. Now, what this method does for the Native Americans is that it removes all non-wanted vegetation, encouraging grass growth, which attract bigger game, allowing for Native Americans to get more food. Now, in our case, for fire management, is just used to maintain native grasslands and open woodlands and the biodiversity within those environments. So prescribed burning, as I said before, stimulates vegetation growth and is a way of controlling fuel load concentrations and fire behaviors. Various articles note that ecological restoration and fuel load management reduction can be accomplished through fire. This causes naturally occurring natural heterogeneity and promotes fire-dependent species within our environments. The Journal of Environmental Management notes that fire spread rate can be facilitated and retarded by landscape heterogeneity. These beneficial strategies, however, as a win-win strategy for us, have its own limitations by our own standards. So recent research from the Springer Open Journal Fire Ecosystem state that fire management managers are susceptible to status quo, which means that they are reluctant to choose the better used practices over their established methods that they're currently using. Now, the limiting factors are societal factors, that is, our funding, conflict of objectives, and priority of resource values. All three of these would limit the usage and implementations of fire beneficial strategies such as prescribed burning. Now, those set aside, environmental regulations such as the Clean Air Act and Endangered Species Acts also limit the usage of these beneficial strategies. I would also like to note that the UE, however, is increasing, makes fighting fires more difficult for the fire department, nevertheless making natural fire burn methods become impossible to use since the housing development rate is growing and kind of encroaching onto the forest landscapes. Now, for my methods to look into wildfire occurrences, I split my hypothesis into three different questions. One is which environmental factors contribute to the wildfire occurrences? Precipitation, drought, soil moisture, elevation, or landscape structure. Question two relates to the National Risk Index and how accurate is its prediction for wildfires, as well as what does it mean for the future? And do these spatial patterns relate to question one? For question three, I go into how can risk response coordination be improved based on question one and two. To move forward, the data sets I use in my methodology range from various sources such as firms, FEMA, ArcGIS Online, the Department of Conservation, PRISM, the Climate Group, the Golden Gate National Parks Conservancy, and the United States Geological Survey. The wildfires in themselves are captured as thermal anomaly data sets from the MODIS satellite. So firms and FEMA catalog and collect thermal anomaly data sets ranging from before 2018 to our current time right now. But for my case and research project, I'm only focusing on 2018 and 2021. Now, as a general overview of my analysis, I'm showing on this slide all the steps within my analysis, but just for time's sake, I'm going to just skip to the important steps here. Now, to answer my first research question, what environmental factors contribute to wildfire occurrence? I am using a linear regression analysis, combining all of my data. First, I'll be using my thermal anomaly data as the dependent variables, separating them into separate years, and then concatenating them each with the other independent variables of environmental factors such as precipitation, soil moisture, and drought data. With these data sets merged into one, I can then export it into a CSV file to use into a linear regression analysis. Now, what this will do is reveal the positive to negative relationships between each environmental variable, revealing the answer to my first question. Now, moving on to the second question of how accurate is the NRI and how can I test it? To do this, I am taking all 4 thermal point layers into one and using a kernel density function to get just hotspot layers of the accumulated wildfires of 2018 and 2021. And I'm taking that layer and overlapping it over the NRI to show the accuracies that the NRI might have. Now, if it does not match up with the spatial patterns, the kernel density that is, then a further analysis would need to be conducted. Now, to do that, I will be taking certain parts of each data set from elevation, soil moisture, precipitation, drought, land cover, and previously burned areas, and extracting those variables from a Boolean function, which are then going to be shoot to a raster calculator to be merged to produce 2 different data sets. Now, each data set is going to represent the same thing, high risk areas, but one's going to represent the non-amendable areas and the other amendable areas that we can actually implement our own prescribed fire management methods. Now, for question 3, how can risk and response be improved? I would like to note that drone technology has been around and has been advancing in its technological areas for quite some time and has been used by the Forestry Department for a long time. High altitude fixed wing drones with multispectral scanners are used autonomously to collect imagery data. Now, drone usage for imagery data acquisition is relatively fast compared to previous methods. It provides near real-time imagery or intelligence of 5 to 10 minutes. Now, drones can carry fixed loads and can carry instruments such as visible light cameras, near infrared, thermal infrared, shortwave infrared, radar, and LiDAR instruments. Now, the drone LiDAR instruments can be used and as a pivotal tool to monitor understory vegetation that has been concentrated and just overgrown. And with that said, it can be sent to the Forestry Department to implement their own practices to maintain that concentration of vegetation. Now, what drones essentially would do is reduce cost of gas, labor, and remove the risk of life factor from the employees that would usually take helicopters or planes out to capture that data, the imagery data. Now, the drone technology can be coupled with AI and machine learning technology. Now, what that would do is it would take the imagery data from the drones and facilitate it and expedite it, the intelligence data that is, to a database, which can be used by various different agencies simultaneously. And as a consequence, produce that intelligence at a faster rate than previous methods. As you can see in the model on the very top of the AI machine learning technology section, the web interfaces as well as mobile and Internet of Things sources can collect the data into the AI machine learning functions, or at least the script. And then once it's been manipulated and edited and set to be used, it can be stored into a database storage, which can be accessed by multiple different agencies. Now, what this would do essentially is it would increase the alert and response times for management to the public, as well as improve fire management as a routine oversight for fuel load concentrations via drone surveillance. And that, yeah, so what the AI machine learning technology would do is pretty much as an automated response, kind of manipulate each data set used by the drone technology and kind of clean it up, in other words, to be used immediately, instead of taking the time, which is costly for the fire department, to be mitigate and facilitate the damage extent of the wildfire occurrences. And that would be the end of my presentation. Thank you for listening.
All right, Matt, thanks for that great presentation.
Yeah.
Wait and see if have any questions in the chat window.
Okay.
Maybe while we're waiting, you could expand a bit on kind of the challenges that you perceive you'll have with the data collection, particularly with the drone data.
With the drone data, I find that well, it has been noted by the fire department as well as the forestry department that drones have been known to be caught within the how would you say, the air disturbances. So as wildfires are created, the air above it becomes very disturbed, very high winds, very strong winds. And so the drone technology would be fighting uphill in essence to collect that imagery, at least clear, resolute imagery to be collected. Now, other challenges I would foresee are included with the data. which is my main concern, since the linear regression would need fine data sets in order to reveal the positive to negative relationships between wildfire occurrences. That is my biggest challenge currently.
I assume that with the flying the drones into the wildfire, there's an incredible amount of thermal energy that's coming off the wildfires, and I suppose you could burn up your drone if you get too close, right?
Yes, correct. This is entirely true. Drones are actually very sensitive instruments. My previous experiences with drone technology are for me, my experiences with it are dealt within the Belize jungle, collecting 3D imagery for Mayan data sets, or Mayan settlements, sorry. But having said that, drone technology is very finicky. Like, it can be immediately shut down due to thermal increases, humidity, as like the water would reach into the motherboard or other components and then short circuit. So yes, there are drone technology, however very convenient, needs to be more robust in order to be to endure the thermal temperatures for wildfires.
All right, well, thanks for that explanation. Why don't you go ahead, and doesn't look like there's other questions here. If you want to, you can put your contact info in the chat window, and if anyone has a question, they can follow up with you at a later date.
Okay, there you go.
Thanks for that.
Of course.
Our last presenter for today is Adam Schinel. Did I say that correctly?
Schinel, very close.
Schinel? All right. So if you want to start sharing your screen, Adam.
Sure. All right, hopefully you can see a blank desktop.
Yes, we see a blank desktop.
All right, and then in just a moment, you should see some slides. I should mention, when I do this, I lose the visibility for the Zoom window. So if anybody, I won't see the chat, so feel free to chime in if needed.
Ah, there we go. Looks good from our end. Take it away when you're ready.
Okay. Well, thank you everybody for sticking around. My name is Adam Schinel, and the project that I will be discussing today for my capstone is creating a GIS-centric web application for the food bank in Central Virginia in order to track their volunteer outreach efforts. And Dr. Holmes has been my advisor this semester. All right, so just a little bit of background as far as why this interests me, why food security. As I've been slowly but surely making my way through the master's program, I've been knowing that I would have to do a capstone project. So I've had things, ideas bouncing around my head for the last couple of years. And the one that has really stuck has been food security. And I think it's just something about food insecurity, especially in a country as wealthy as ours, bothers me, especially when you juxtapose how much food there is and how much waste there is of food. When you juxtapose that with the fact that there's still hungry people in our community, it's a little bit hard to take, at least for me. And I remember a story my mom told me. She was involved with her community, and they were asking school kids, did you eat breakfast today? And for the ones that did not eat breakfast, they were finding out why, and some of them, I don't like breakfast, or in a hurry or whatever. And one of the children said, it wasn't my turn. And that's the kind of thing that's just like, ugh, like we can do better somehow. And so, so food security and kind of connecting the dots as far as extra food and people who need extra food, to me, it seemed more like a logistics issue rather than supply and demand. My original idea was to, and I'll just switch to the next slide now. My original idea was to connect the dots as far as people that have extra food with people that need extra food, knowing full well that a food bank could be in the middle. And when I say people that have extra food, I was thinking of restaurants, catering services, farms, grocery stores. With the exception of farms, I've worked in all of those and can attest to the fact that there are lots of instances where there's just tons of free food and it ends up going in the trash because there's no one there to make use of it. So that was one idea I had. The other idea was on the other end, from say the food bank to the people that need it. So more on the distribution side of things. Both of which I thought would be good candidates for a GIS web application. However, I knew, I wanted to make my project a practical application, and I wanted it to be usable by the food bank or whatever organization I designed it for. And so I knew going in that my ideas might change. Either the needs I just talked about had already been covered, or there was something else that made more sense for them. So those were my original thoughts, but then they changed a little bit, as I'll get into here shortly. So just recently I moved to the Richmond, Virginia area, and Feedmore is the food bank for the Central Virginia region. And I knew it was big. And after talking with their folks, it's even bigger than I had originally realized. It's 29 counties, 5 cities. They do a ton of stuff. When you go to their facility, it resembles a warehouse. They have pallets and pallets and pallets of food. They make their own frozen meals. They make their own frozen meals based on dietary requirements of their clients. They even do pet food if the clients have pets. And so there's a lot that goes into it. It's a very big organization that largely from the operations standpoint, as far as I can tell, runs like a pretty well-oiled machine. So in order to start engaging them, I put in a volunteer application for a Meals on Wheels delivery driver. And I should say several years ago, I forget the exact date off the top of my head, but the Central Virginia Food Bank and Meals on Wheels in this area merged to become Feedmore. So they are a food bank as well as a distributor with Meals on Wheels. And so I put in a volunteer application and said, hey, I'm interested in being a driver. And they also had a section on there for additional skills. And one of the ones to choose from was data analysis. So that made me optimistic, that if they're soliciting for that kind of help, maybe there's something to do here GIS wise. And so shortly after that, I was put in contact with Timothy Both, who's their director of volunteer engagement and strategy. And after a couple of conversations, sitting down with him and talking through what they're doing and what their needs are, we identified a way that a GIS application could benefit his efforts. And so what we talked about was not either of my original 2 ideas, the connect the dots ideas in that regard. But what he did say he needed was a way to track their volunteer outreach efforts, both where they could go, where they have gone, where they've been successful, where they've not been successful. And it's worth noting they are the Meals on Wheels portion is a pretty massive operation. They got hundreds of routes. Prior to COVID, they were running those routes daily. Once COVID started, they scaled back greatly to an every other week delivery schedule. But with Meals on Wheels, and then going through their onboarding for that, it's more than just food. These are homebound individuals, oftentimes elderly folks. And so just a personal interaction and a very quick wellness check on the part of the delivery driver are part of it, more than just, hey, here's your box of food. So there's a lot of reasons why they want to return to that 5-day-a-week schedule. However, in order to do that, they need to recruit over 1,000 extra volunteers from where they're at now. And they are slated to return I don't know if they have a firm date, but it's in the basically springtime of 2022 is when they're targeting that, assuming they can get the volunteers they need. So that's kind of a new thing coming. It's, you know, they've needed volunteers in the past, but with COVID essentially resetting everything, they're going to have to kind of dig out of a hole to get enough volunteers for their operations. Timothy Both, the gentleman I mentioned on the previous slide, is fairly new to that organization. And as such, he has some ideas for things that they haven't done a lot in the past. One of which is volunteer outreach. In the past, I guess they've relied on what he called name recognition quite a bit for volunteers to come to them, the way I came to them. But he said, you know, really it would make sense for them to do some dedicated outreach too. And so when he says outreach, he's talking about targeting organizations, employers that have dollars for doers programs, as he said. So people that incentivize volunteerism one way or another. Rotary clubs, schools, faith-based organizations, things like that. So in order to recruit actively, as opposed to just setting up a table somewhere and passively waiting for people to walk by. So actively engaging the community is one of his big initiatives, and something that it sounds like they haven't done a whole lot of in the past. And so as we were talking, his biggest question was, where do I start? Not just, literally where, like what locations do I need to go to? And I looked at him and I said, are you starting with Google, the way I would be doing, or do you have a spreadsheet or something? And it was basically Google. He would be searching around for places to go, try to engage to get volunteers. They did have a little bit of data they could harvest from their previous efforts, but it's not like they had this big, easy to use database just for that purpose. And it certainly wasn't GIS enabled or anything like that. So, so that was one of the big things that we realized. And in addition to where to begin, he's a technically minded guy. He might not write code himself, but he's very aware of the kind of questions he wants to ask and the fact that technology should be able to help him with this if he has the data he needs. And so he wants to be able to answer questions like, how effective are our efforts? If we, went to this organization 3 times in 3 years and heard crickets, maybe we either need to change our approach, or maybe that's just not going to be a successful venue for us. And, of the volunteers we get, how long are they staying with us? Because volunteer turnover is a constant thing they have to deal with. So even after getting ramped back up post-COVID, he said, this type of application is going to be necessary in the future as well. So that's kind of like step 2 down the road, but probably not too far down the road. He wants to be able to start doing some analysis on his data and getting smarter, essentially, as far as how to target their resources. It's also worth mentioning they have what they call a volunteer management system. This is also another new thing. Or I should say they just got it upgraded to a new system, and it's called Volunteer Matters, and that handles basically the volunteer sign-up process and allowing volunteers to sign up for events. And I asked him, I said, I don't want to reinvent any wheels. Is this, can that software be configured to do what we're talking about here? And he said, no, not without some very expensive customization. So, and I'll mention that because a little bit down the road, hopefully we'll be able to integrate with that system in one way or another. All right, so that was the gap. We literally where to begin and collecting data to go with that. So that to me sounds like a good candidate for a GIS web application, as well as getting some data, some breadcrumbs so that they can analyze their efforts in the future and hopefully link up with their volunteer management system as well. So this is my rudimentary sketch of the solution I have in mind so far. And I should also mention the approach I'm taking is going to be open source. I asked them, I checked to see if they had an organizational Esri license. They don't. Dr. Holmes and I kind of kicked around the idea, and she did some checking for me, which I appreciate, to see who at Esri might we ask about getting a free license for a nonprofit kind of thing. But after talking with Timothy, I kind of abandoned that idea because even if the license was free, you would still need someone to administer it, IT resources, all that kind of thing. So, so for multiple reasons, I decided to go with open source. And so what we're looking at here is the front end. And can you guys see my mouse cursor?
Yes, we can.
Okay, cool. So step one, or item one on this list, is the web interface itself. And if you heard me say open source, and then you're looking over here and see Esri, you might say, what are you talking about? Their JavaScript API is open, and you can plug in data sources that are other than an Esri published REST endpoint, to include a web feature service and a web feature service with transactions enabled, which I'll need for this project. So that would be the front end. And if you're wondering why that instead of Leaflet or something else, I've used the JavaScript API before. I like it a lot. The front end is pretty clean. The documentation is very good. So that was my reasoning in doing that. And then if they do get Esri backend in the future, that might be an easier plug and play from that respect. And then we'll also need a cloud-hosted database. And for this, I chose Postgres with the PostGIS extensions enabled. And that's just going to serve as the data store for all these locations, all these dots on the map that are an organization and the related data that goes with it. All of this, represented by this dark blue box here, will be living in the cloud. And I mentioned this to him. I said, hey, for the initial deployment, I have my own little online service that I use for side projects and just tinkering around and stuff. And so I have something where they can get off the ground with it. Down the road, they may decide to deploy it on their internal servers. But for now, at least the initial deployment will be cloud-based. And one other thing I should mention too is this will have to be secured, because the information that they store, such as the donor point of contact information, the donation history, things like that, I would certainly consider sensitive. I'm sure they do too. So that could necessitate the use of additional technology to secure that. Something like a fast API for Python is what I've found so far. All right, and then as I was starting to say a slide ago, they have this volunteer management system, and there's good data going in there about the volunteers themselves, when they volunteer, all that stuff, how long they stay with it. But from talking with Timothy, it sounds like it might be a little bit hard to mine, or at the very least, not super valuable in and of itself. So if we can have something like a GIS application with a database that says, here's my locations, here's my events associated with those locations, and then there's a link between systems, whether it's event ID or something like that, that Volunteer Matters and the GIS app are both making use of, then you can start to bridge the gap and answer some of those questions he had. How well are we doing? What's the ROI for volunteers? One of his basic questions was, how much does it cost money-wise to recruit a volunteer? If you average it all out, what does that cost us? So hopefully we can start doing some of those, answering some of those kinds of questions when we marry up the data from the two systems. As a bonus, this project can dovetail with a separate ongoing effort of Feedmore's, and that is trying to ensure that its volunteer base reflects the communities that they serve. So essentially, they want the delivery drivers to be ideally delivering to folks in their neighborhood or around their neighborhood, rather than a bunch of out of towners, if you will. They have a separate volunteer with a GIS background who is plotting that out for them and kind of using census data as a background to say, what are the demographics of your volunteers? What are your demographics of the folks they're serving, and where are they? And so if we take that type of data and layer it with the locations that they can potentially recruit from, if they see a hole, in their volunteer base in terms of a geographic area, and they have some sites there to go recruit from, that could be kind of a natural next step is, hey, why don't you go talk to these 5 businesses or churches or Rotary clubs in this area to support your goal of getting volunteers that reflect their communities. All right, so as far as next steps go, I've begun this a little bit, but really it'll begin in earnest after this semester. And that is starting to design and prototype the technical solution. I kind of half joked with Dr. Holmes that this is essentially GEOG 585 on steroids. And I think I'll use a lot of that as a starting point, but then there's going to be more to it as well in terms of, being able to perform the create, read, update, delete operations back and forth and having that live and the security and things like that. So designing and prototyping that, starting with their basic Excel sheet now, which I have geocoded and have the basic dots on the map, using that as a starting point. And then kind of from there, fleshing out what the data model should look like, what data needs to live where, and importantly, how are we going to link this data, the location data, the event data, with that volunteer matters data so that we can kind of track the success of your efforts over time. And to me, I think that's probably the biggest known unknown is what that link will look like. Timothy and I talked about it, but their system is just, their new Volunteer Matter system is just going live at the first of the year. So they've been kind of in beta testing up until now. And so there's certainly some stuff that's a bit of a moving target for this project, but nothing I don't think can be overcome. So yeah, so that's what I'll be working on next. And with that, I will open it up to any questions.
All right, Adam, thanks a lot for your great presentation. Wait for questions to come up in the chat window.
Sure, and I'm going to minimize so we can see any as well.
While we're waiting, I'll ask a question. How much support, either financial or otherwise, is given to the food bank, either at the local level, county level, state level? Do any funds or other resources sort of trickle in?
It's a good question. As far as like state-sponsored stuff?
Yeah, I mean, state, local, and any sort of sort of formal governmental or administrative structures.
To be honest, I'm not sure. I know they have partnerships with lots of local businesses, and I think he said they have over 900 partner agencies. So they, there's quite a few folks that they're involved with. And anecdotally, I have seen that food banks in the US in general do get assistance from government entities. But I'm not, I can't say for certain what or how much.
Right. Right. Okay. All right. Looks like you have some questions in the chat window.
Yeah. So, so Blake is asking, can you briefly explain how your JavaScript or how the Esri JavaScript API will talk to your database? Yes. And so that, the way I envision that working is there is, oh, it's probably buried in one of my 75 open tabs, but they have what's called WFS-T, which is Web Feature Service with transactions enabled. So in 585, we published out a Web Feature Service, and it was, static, read-only. But the idea here is if you publish it out with transactions enabled, that'll allow users to add a new dot on the map or edit the attributes for an existing dot on the map. And Esri supports that as a data source, and they support the transactions. So kind of like just using the JavaScript API with an Esri data source, it's just a different one. I hope that answers the question. Cool. And then Andrew's asking, he's wondering about the size of my study area for this application, and are you targeting specific residential addresses for volunteers or general regions? So if we go, it might be a little hard to see in this one here, but the hatched area in Virginia is Feedmore's service area. So it's quite big. A lot of their existing volunteer base comes from right around in and around the Richmond area. As we can see, their service area extends well past that. So my thought would be, as we get dots on the map, and I've already seen some patterns already, like they were saying, oh, south of the river is hard to recruit from and blah, blah, blah. And I looked and I was like, well, it could be a chicken or the egg thing because you don't have many sites south of the river that you've targeted. So it could be a little bit of that starting to, where do we need to fill in? And then, like I was talking about earlier, if we can overlay that with their existing volunteer data that the other lady is working on for a separate GIS project, then to me, that'll kind of make things pop out as far as here's where we need volunteers, whether it's right around Richmond or whether it's, in the southwest corner of their volunteer, or excuse me, of their service area. It'll kind of make that pop out. You need volunteers here, and either here's some places, some organizations that you can go contact, or you also have a lack of organizations, and so maybe that's why you don't have many volunteers there. But either way, I think putting those two together will be a powerful thing in the future. Hopefully that answered Andrew's question. And then Mark is asking, could you use census income data to correlate to volunteers? And I believe that's exactly what the other GIS volunteer is doing with her project, is mining the census data to say not only what the client base looks like, but also trying to figure out some demographics for the volunteers themselves.
All right. Let's see. If you want to put your email in the chat windows, folks can contact you later if they have a follow-up question.
Sure.
Otherwise, thanks again, Adam, for your presentation. I'd like to take this time to thank all of our presenters for a really great round of capstone project proposals. We'll certainly be anxious to see how they mature over the next little bit, and then the presentations in 596B, be it virtual or in person at a conference. So for the presenters, make sure that you complete the peer review form. The link is in the window. And best of luck with the rest of the term. And we will see you here at some point next year. Have a good day.
Sounds great. Thank you, everybody.